Welcome to Ramta Solutions and welcome to your grade 11 trigonometry lesson. Today we are looking at past papers, and in our past paper series, the past paper that we're looking at today is the past paper written by the Gauteng province in November 2022. Okay. It was written by the Gauteng province in November 2022. So let me open this paper. Here is it. I'm going to pin it so it appears on top of everything. Okay, so without any waste of time, let's go. I will have to zoom it in. So now the key instruction that I like focusing on is this one here. Where necessary, round off answers correct to 2 decimal places unless stated otherwise. Okay, when necessary, round off answers to 2 decimal places. This is very important. Now, another one that I think I should also bring your attention to is this: answers only will not necessarily be awarded full marks. So try to show how you came to your answer where necessary. Okay. All right, so let's get to our questions. Trigonometry is normally question 5. And remember, guys, if you're using a mobile device, please rotate your screen so that you have the better viewing. Now, without any waste of time, let's get into it. Question 5, it says, 5.1, determine the value of the following without the use of a calculator. 5.1, we're determining the value of tan 180 degrees minus x multiplied by cos 360 degrees plus x, all these over 2 cos 90 degrees plus x. Okay, so what we know, tan in the 180 minus quadrant is negative. So this will be negative tan x. Again, now let's look at cosine. Cosine in the 360 plus. What's 360 plus? Remember, guys, these unknown angles are acute angles. So 360 plus is the first quadrant. Cosine in the first quadrant is positive, right? It is positive. Now, cos in the 90 plus quadrant, is it positive or negative? It's negative. So maybe let me write this as negative 2. And because it's 90 degrees, it'll change. It'll be sine. So it's negative 2 sine x. Okay. Now, as you can see, we have negative and negative. So basically, it becomes positive. So proceeding, we will say, now let's see. We will say tan. We know that tan is sine x or sine over cosine. So tan x is sine x over cos x. So sine x over cos x multiplied by cos x all over 2 sine x. Remember, the negatives got cancelled. Okay, so as you can see, guys, cosine cancels with cosine, sine cancels with sine. So what does this mean? This means our answer is half. Okay, this means our answer is half. How many marks is this? This is 6 marks, and you were able to finish it within 6 marks, or rather 6 minutes. Now, let's go to the next page. 5.2 says, giving the identity, let me see, giving the identity, that one, prove this identity. So when we prove this identity, 5.2.1, I prefer the one that is easy to simplify is the left-hand side, because the right-hand side, really, there's nothing that we can do. So let's take the left-hand side. So we say the left-hand side equals sine theta. Okay, sine theta minus 2 sine theta cos theta all over 2 cos square theta plus cos theta minus 1. So what I see in the numerator, we have a common factor sine theta. Okay, so we are left with 1 minus 2 cos theta. All right, in the denominator, this is a trinomial. Now this trinomial, we can simplify it, or rather we can factorize it by saying this is 2 cos theta, I'm going to say minus 1, and then cos theta minus 1. However, the bigger factor must have the sign of the middle term. So the bigger will be this one here. Okay, it will be this one here. So I think we are good to go. Isn't it? We are good to go. However, when you look at this, in the numerator you have 1 minus 2 cos theta, but in the denominator you have 2 cos theta minus 1. So these are not the same. So it's up to you which one you want to rearrange. I prefer we rearrange the numerator. So when we rearrange the numerator, I will say if we take negative as a common factor here, we will be left with negative sine, sine theta. Okay, negative sine theta into, okay, it's messy. I had forgotten sine theta. Let me just squeeze it. Sine theta. Okay, it's better. So now we said we take negative as a common factor. When we take negative as a common factor, or negative 1 as a common factor, it'll go out. And then what does this mean? It means we can rearrange and say you become, if you took negative as a common factor, you become positive and you will become negative. Guys, remember, the reason this is the case is because if you look at it, if you say negative times positive, it will become that negative 2. And then negative times negative, it will become that positive 1. Okay? All over 2 cos theta, oh boy. All over 2 cos theta minus 1. And then cos theta plus 1. Okay? As you can see, these guys are cancelling. Right? These guys are cancelling. So that means we are left with negative sine theta over cos theta plus 1. This is equal to the right hand side. Okay, this is equal to the right hand side. Right? So we have proven this identity. Right. Perfect. Now, for which values of theta 5.2.2, 5.2.2, for which values of theta will the identity be undefined? I advise you don't use the right hand side. Rather use the left hand side. I think the left hand side will be sufficient. It will give you more detail. Okay. And before you answer this question, pay attention. This says for which values of theta will this identity be undefined? They didn't give you a domain. So since they didn't give you a domain, by that I mean they didn't say X is an element of whatever. So that means you must do the general solutions. Okay, so let's not waste any time. So we're looking at the denominator of the left hand side. Remember, for a fraction to be undefined, denominator must be 0. So that means denominator, which is 2 cos square theta plus cos theta minus 1 must be equal to 0. And this, we said it will be 2 cos theta minus 1 cos theta plus 1 equals 0. I think that's what we said, isn't it? That's what we said. So now, when you look at this, okay, it'll become, let's look at it, it'll become, what is this? Cos theta equals equals half, or cos theta equals -1. So here, your reference angle is cos inverse of half. That is cos inverse of half. We know what it is. And here, let me just squeeze it here. A reference angle is cos inverse of 1. Remember, you don't consider the negative side. So what is this? Cos inverse of half is 60 degrees. You are using your calculator. And here cos inverse of 1 is 0 degrees. Okay. So now for our general solution, let's begin. For this one, we say cos theta is positive. Why is cosine positive? In the first quadrant. Right? In the first quadrant. In the first quadrant, what do we deal with? We deal with our angle was theta. Okay, so we deal with theta equals reference angle is 60. So it will be 60 degrees plus. Because it's cosine, it will be 60 degrees plus 360 degrees k, where k is an element of an integer. Now, for this guy again, he's positive where? Cosine is positive as well in the fourth quadrant. So in the fourth quadrant. Right, in the fourth quadrant. So in the fourth quadrant, we deal with 360 minus. So it will be 360 degrees minus 60 degrees plus 360 degrees k, where k is an element of an integer, isn't it? So what does this mean? This means theta is an element of 360, oh boy, 300 degrees, not is an element. Theta is equal to 300 degrees plus 360 degrees k. Okay. Now, let me go back to the previous page. As we go back, we also said cos inverse, rather cos theta is equal to 0. Let me fix this, it's messy. So cos theta is equal to -1, by the way, sorry. So cos theta is equal to -1. So this means cosine is negative. So cosine is negative in the second and third quadrant. We will not waste our time. For this one, we will say third quadrant, because I don't have enough space to write the two of them, but maybe I should move this guy a bit to, yeah, I'm going to move it shortly. Okay, okay. So for the third quadrant, whether you take the third or the second quadrant, it doesn't matter, but you will get theta equals 180 degrees. Remember, in the third quadrant, it's 180 degrees plus, it's 180 degrees plus. So this is 180 degrees plus 0. Come on. Anything plus 0 is that thing. So this will become 180 degrees plus 360 degrees k, where k is an element of an integer. And this is where we leave it. These are all the values of theta where the identity will be undefined. Okay, this is where the identity will be undefined. So we're using this general solution because they didn't give us the effect. 5.3, 5.3, how many marks was this? It was 5 marks, so cool. 5.3 says, in the diagram below, A is a point on the Cartesian plane such that angle AOT is alpha with OA equals 4. Okay, with OA equals 4, P having coordinates K and M is a point such that OP is 6 units and AO is perpendicular to OP. Cool. So where's the first question? 5.3.1, determine the value of P. We're not going to waste our time. We know that if we draw a line here, it will be perpendicular to the x-axis. So this is where we use Pythagoras theorem. And we know 5.3.1, we know Pythagoras theorem, r squared equals x squared plus y squared. What is r? R is, they give it to us, this is 4. So it's 4 squared. What is x? It's given as b. What is y? It's given as 1. So this is 16 equals b squared plus 1. So 15 equals b squared. So b equals plus minus square root of 15. However, where is b? Guys, b is in the negative x-axis part. Right? It's in the second quadrant. So x values on this side are negative. Therefore, we conclude and say b is negative square root of 15. Okay, b is negative square root of 15. Okay, as simple as that. How many marks is this? I know this is a long procedure, but it's okay to first begin here. Okay, you need to be sure of whatever that you're doing. Okay, but if you have any shortcuts, it's okay. Right, proceeding for 2 marks. Now 5.3.2, determine without the use of a calculator the value of tan alpha. All right, let's go. We're looking for the value of tan alpha. Okay, when we look for the value of tan alpha, I want to show you something here. You see, when you write this guy here, okay, you call him alpha. Okay, you call him alpha. This was A with B and 1, and this guy was 4 units, right? So when you're looking for tan alpha, your expectation is that alpha is an is an obtuse angle, and tangent in this point is negative, right? So what we are going to do, we're going to say, okay, tan alpha, I'm not going to waste my time. I'm going to call this portion here the alpha that I'm really interested in, because the reason you're doing a reduction formula is to write your angles in an acute form. Okay, so number A, we do have x and y and r. So tan alpha will be, what is the value of remember, tan is opposite over adjacent, meaning it's y over x. What is the value of y? The value of y is 1. What is the value of x? The value of x, we found it to be negative 15, isn't it? You can leave it here, guys. If you like, you can also use your okay, you're not using your calculator, but you can rationalize the denominator. Okay, you can rationalize the denominator. Okay, all right, perfect. So when you rationalize the denominator, you will be getting this answer. It will be negative square root of 15 over 15. Okay, the square root of negative square root of 15 over 15. Okay, this is when you rationalize the denominator. There's a video on rationalizing the denominator in our channel. We do have that. Let me say that. I'm not sure if we put them in a playlist, but we do have that. Okay. Proceeding. Now, question B says, this is supposed to be like this: sine negative alpha minus 180 degrees, close bracket, plus cos negative alpha plus cos negative alpha. The reason why this question paper looks so weird is because there's a comment. Okay, so this comment says bracket missing. So BK, who is the one that wrote this question paper, made this comment. Okay, all right, guys. So now let's proceed. Now we don't have something like this where we work with alpha minus 180, right? So what we can do, I'm just going to show you this slowly. We take negative as a common factor. Okay, when we take negative as a common factor, let me just do this. I will take it out because I took it as a common factor. We will be left with 180 plus alpha. Now, negative angle of cosine is just a positive angle. Okay, cool. Now, what is cosine? Sine in the 180 plus quadrant. Sine in the 180 plus quadrant is negative. So that negative times this negative will be positive. So we will be left with sine alpha plus cos alpha. Okay. Now, what is sine alpha? Remember, sine is opposite over adjacent. What is opposite? That is basically sine is opposite over hypotenuse. So that means sine is y over r. What is y? Y is 1. What is r? Is 4. Now let's look at cosine. Cosine is adjacent over hypotenuse. What is adjacent? Adjacent is x. Alright? Adjacent of alpha is x. So it will be minus root 15 over 4. When denominators are the same, you add your numerator. So this is you add your numerators. So your answer is 1 minus square root of 15 all over 4. Okay, all over 4. All right, perfect. Now, how many marks was this? Okay, 3 and 2. Okay, cool. Proceeding. Let's go to the next page. 5.3.3. Without the use of a calculator, determine the values of K and M. This is interesting. So, guys, something that you need to know is this. I need to draw this because I need to bring something to your attention. This from here, this is alpha and this is 90 degrees. Okay, O, P, A. I'm not gonna put those points there. This is alpha, right? So alpha is from the x-axis. Alpha is from the x-axis to OP, right? But angle AOP is 90 degrees. What is this portion here? You guys must agree with me that this portion here, somehow one can say, if you want to get it, you know what this is and you know what this is, right? This is 180 degrees. I mean, it's alpha. So what is this? Somehow it means this one must be alpha. Should we say alpha minus 90? Even if we say 90 minus alpha, it's okay. But alpha minus 90 would work, isn't it? Alpha minus 90 would work, isn't it? All right? Alpha minus 90 would still work. Okay? So if you take this to be alpha minus 90, okay? This portion here is alpha minus 90. It can work. So now let's talk. So if we say this is alpha minus 90, look at it. Let's say this is alpha minus 90 degrees. Okay, alpha minus 90 degrees. So what is point P? Point P had coordinates K and M, meaning this guy here is M and this guy here is K. Okay. All right. So now I'm going to say, what is this? We're going to say, let's begin with sine. I'm going to say sine alpha minus 90 degrees is equal to, what is sine alpha minus 90? Oh, by the way, this guy was 6. This guy was 6. So sine alpha minus 90 will be, sine is opposite over hypotenuse, which is M over what? Over 6. So what is this? We're not used to it like this. So take negative as a common factor, right? Take negative as a common factor, right? So if you take your negative as a common factor, guys, be careful. If you take your negative as a common factor, don't worry. Negative as a common factor, we will be left with negative 90 degrees minus alpha equals M over 6, isn't it? Now, check this out. We have sine 90 minus. So sine in the 90 minus is positive, right? It's positive. Now, having said that, because of the 90, sine has to change. It'll be cos alpha. Okay, so negative cos alpha is equal to M over 6. Now, what is cos alpha? Cos alpha is, if you recall, cos alpha is, let me go back. Still remember, we found our x value to be negative root 15, right? We found our x value, which is b. We found it to be negative root 15. Okay, let's go. So it's negative root 15 over 4, isn't it? Equals M over 6. Negative times negative. Well, this therefore means M is equal to 6 over 4 is basically 315 over 2. Okay, it's positive, guys, because negative times negative is positive. Okay, and indeed, we're expecting this value to be positive. Can you see that? Perfect. Now, we're going to look at cos alpha minus 90 degrees. So what is cos alpha minus 90 degrees? Cos is adjacent over hypotenuse. So what is it? Adjacent. It's k over 6. So again, this is negative because you take negative as a common factor, is negative 90 degrees minus what? Minus alpha equals k over 6. Okay, so what is this now? We have negative at 90 degrees. We'll change this to sine. So it'll be negative sine alpha, which is equal to k over 6. Okay, which is k over 6. Hold on. You will need to do some manipulation. But so far, whatever that we have done is okay. What was sine alpha? Sine alpha was 1 over 4. Check this out. This is negative 1 over 4 equals k over 6. So what you're seeing, we can therefore say k, let me not say therefore, let me just say k seems like it's minus 6 over 4 reduces to 3 over 2. But come on, you don't expect your y value to be negative here, right? You don't expect your y value to be negative here. So therefore, we will conclude and say k equals 3 over 2. Reason being, p lies in the first quadrant. Okay, p lies in the first quadrant. The reason I am writing this statement, guys, it's because, look, you see, when you write your exam, you must make sure that your marker is your friend. Let things make sense to your marker. Okay, let things make sense to your marker. So this is it. And this is how we get our marks for this question. Okay, this is how we get our marks for this question. Okay, perfect. Right. Now, let's see. Are we done with this? Oh, we're done with this question. Okay, now we have to go to... Okay, now we have to go to graphs. Oh boy. So in the diagram below, the graphs of f of x equals a, b sine x plus 1, and g of x equals 2 cos into x plus p are shown for the interval x is greater or equal to negative 90 degrees, but less or equal to 180 degrees. Okay, cool. So let's see now. This is question 6, by the way. This is question 6. So write down the amplitude of 2. Guys, when they say the amplitude of G, not 2. 6.1, the amplitude of G. Amplitude, you look at the formula, the coefficient of your trig ratio is your amplitude. So this is simply 2. Or, if you like, amplitude, when you're looking at your graph, amplitude is maximum minus minimum value over 2. So what is our maximum value for G? Our maximum value for G is 2. What is our minimum? Our minimum is minus 2 on over 2. What is our answer? It's simply 2. That is your amplitude. Okay, that is your amplitude. Remember, I am also trying to show you guys how you get your answers. Okay, so we're not in a hurry. Of course we are, but the aim of having such a video is to help you to get the best out of this. And by the way, guys, if you're watching this video between the first term and the second term and you're in grade 11, you don't have to continue watching to this point. But if you are watching after the second term, please continue watching. Okay, perfect. 6.2, determine the period of f. When we say the period, we are basically saying when do we get a complete wave. So your function starts here. Okay, as you can see, it starts here. Between 0 to 360, it starts here. And look at this. This is half a wave. This is a full wave. Remember, a full wave is made of a minimum and a maximum. So it starts here, half of it, and it ends here. So what is our period? Our period is 120 degrees. So 6.2, our answer is 120 degrees. 6.3, determine the values of A, B, and P. 6.3, A, if you want to know the value of A is the amplitude, okay? A is the amplitude. I have shown you amplitude is maximum minus minimum all over 2. Now let's see for F, right? So B relates to F. So where is F? This is F. What is the maximum? It's 2. What is the minimum? It's 0. So 2 minus 0 all over 2. What is it? A is 1, isn't it? And remember what I said, guys. Amplitude is maximum minus minimum all over 2 when you look at your graph. So maximum is 2, minimum is 0. 2 minus 0 all over 2 will be 1. So our amplitude is 1. Okay, our amplitude is 1. Happy? Right. Now, let's look for the value of B. The value of B, basically, to get the value of B, we do know that period, is equal to 360 degrees over B. When we refer to sine, this is referring to sine and cosine graphs, right? Cool. So the period we found was 120 degrees is equal to 360 degrees over B. So this implies B is 360 degrees divided by 120. It's 3. Guys, I am able to tell that our B, the value of B is 3. But I want you to convince yourself that what we can also find it using a formula that we know. Okay, that means doing what I did. Okay, so B is equal to 3. Now let's look at the value of P. Now the value of P, normally cosine graph, first maximum will be at x equals 0. But here, that maximum has been shifted to the left, right? And we know when you shift to the left, P is positive. So this has been shifted to the left by 30 degrees. So shifting to the left means P is positive. So this is positive 30 degrees. Okay, this is positive 30 degrees. Okay, right, perfect. Now we are done with 6.3. Okay, we are done with 6.3. Now let's look at 6.4. Oh boy, 6.4, we're going to look at number A. Says g of x is greater than 0. What does it mean? G of x is greater than 0 basically says this function is above the x-axis. So where's g? This is g. Where is it greater than 0? Remember, g is a y value. Where do we find its y values greater than 0? As you can see, when x is greater than negative 90 degrees until 60 degrees, not touching them. So we can say this is when x is greater than negative 90 degrees but less than 60 degrees. Remember, they said greater. So any point less than 60 degrees but any point less than 60 degrees but greater than negative 90 degrees is positive. It has a positive y value. Okay, and this you can see here, positive y value. Right? Perfect. Number B, they say f of x is greater or equal to g of x. What it means is that these two graphs are equal, and again, if they are not equal, f of x is above g of x. Okay, let's look now. I want to help you understand this. Wherever you see f of x is greater or equal to, look for intersections. As we look, this is an intersection. To the left of this intersection, g of x is above f of x. That's not what we're looking for. To the right, okay, it's something. So we can stop here. Let's say here, x equals negative 30 degrees. Right? X equals negative 30 degrees. So at this point, as you can see, both graphs are equal. Right? Are equal. It's one of the conditions. Now, they are equal, but to the left of this point, g of x, f of x is below g of x. That's not what we're looking for. Now, to the right of it until point M, again, g of x is still below, it's still above f of x. That's not what we're looking for. We want f of x being above g of x. Now, as I look at it, to the right of this point, which is 48.05 degrees, to the right of it until 180 degrees, that's what we're looking at. So we are also looking at when x is greater or equal to 48.05 degrees, but less or equal to 180 degrees. Okay, but less or equal to 180 degrees. Right? Perfect. Now, okay. Now we have, why did I say B? Oh, they didn't say B. This is 6.4.1, and then this is 6.4.2. Oh boy, 6.4.2, 6.4.2. So now we're looking at 6.4.3. 6.4.3 says f of x times g of x is less than 0. So, guys, f of x times g of x is less than 0. What it means is that where it basically says if one is positive, the other is negative. Are you guys following? If one is positive, the other is negative. Okay. I hope you guys got that. If one is positive, the other is negative. Okay. I like using points of intersection. To the left of the point of intersection, they are both positive. It doesn't help us. To the right of the point of intersection until the next point of intersection. Let's see. Both of them are positive, and at some point it's 0. So we are not looking for that. As we go to the right of this point of intersection until 60 degrees, both of them are positive. Interesting. Remember, they said less than, they didn't mention, so be careful. So we will say now, it seems, I want you to look at it, to the right of 60 degrees until 150, but shouldn't touch 150 because at 150, one of them is 0, which if you say 0 times any number is 0, it will not be true for this. So we will say when x is greater than 60 degrees, but less than 150. Remember, 150 because, I'm saying less than 150 because it's not supposed to be 150. If it's 150, it will be 0 times whatever value here, which is 0 times minus 2, it will be 0. And 0 is not less than, it's not negative, right? 0 is not negative, it's neutral. So, now, again, this is when x is greater than 150 degrees, but less than 180 degrees. And then you get your marks. How many marks? It's supposed to be 2 marks, ne? You should make such 3 marks, eh? So yeah, okay, cool, it's 2 marks indeed. So this is how you answer these questions. Okay, perfect. Oh, we're not done. Come on, buddy. Let me see. Oh, I moved too quick. Okay, now given g of x 6.5 says h of x is equal to g of x plus t. I want you to look at okay, but before then, I determine all values where this h of x is equal to h of negative x. What does it mean? It means h of x is also equal to g of x plus t, isn't it? H of minus x is also equal to g of x plus t. So we have to be careful. Now, something that I want you to see is this. When you look at this diagram, it has shifted 30 degrees to the left, isn't it? It has shifted 30 degrees to the left. Now, if you were to make h of x, which is this g of x shifting, I don't know whether to the left or to the right. If you were to make it to be equal to its, what is this? To its reflection, what do you need to do? And guys, read this question properly. It says, this question, I looked at it and I'm like, wow, this is what I call an exam. And I understand why they had to put it like this. And this is why I love Gauteng papers. By the way, papers that I love are from Gauteng and Eastern Cape. Also, it's just that the best performing province, their question papers are not that easily accessible. But yeah, I'm talking Free State. But yeah, I love Gauteng and Eastern Cape, also because they are available. So, they said h of x is equal to g of x plus t. Now, we must determine all values. Highlight all, it's even in capital letters. Determine all values of t where h of x is equal to h of negative x. Right? So I say, for one, I want you to look at this. Okay, I want you to look at this. The period of our cosine or of g of x is 360 degrees. So that means wherever you get a point, you will get it after 360 degrees. So I'm trying to say, for this to work, g of x has to be moved 30 degrees to the right. So if you move 30 degrees to the right, it means this t must be negative. So I say t will be negative 30 degrees, okay? It will be negative 30 degrees plus 360 degrees k, where k is an element of an integer. Think it was going to be nice if I had drawn this to show you what I mean. But I hope you guys understand that I'm saying for this to work, the graph, because they say it has to shift, don't know whether it shifts to the left or to the right, but for this to work, it has to shift to the right. So when it shifts to the right, it will shift to the right by 30 degrees. So this is where you say you have g of x minus 30 degrees. All right, what is it? It is, if you remember, we said p was 30 degrees. So it will be 2 cos x minus 30 plus 30, okay? Which will be 2 cos x, as simple as that, okay? As simple as that. Now, I'm going to show you, this is what we call h of x, okay? This is what we call h of x. Hold on. Remember, we said h of x is 2 cos x. Did I say 2? Okay, yeah, 2 cos x. Now, what is h of negative x? Look at it. It is 2 cos negative x. What is that? Isn't this 2 cos x? Agree with me that this is the same as what we said was h of x, isn't it? Can you guys see that? This is it, and this is how we do it. Okay, so cool. So when your function shifts to the right by 30 degrees, this is what you will be getting. So I have shown you without even drawing a graph. Okay, happy? So your answer is here. T is equal to negative 30 degrees plus 360 degrees k, where k is an element of an integer. Remember, I said the reason I'm using 30 degrees, 360 degrees k is because g, its period is 360 degrees. As you can see, its period is 360 degrees. How do we know that? Because its coefficient is 1. Okay? Now we have to go to question 7. In the Northwest, they say potso ya bosupa. Okay, in the Northwest, they say potso ya bosupa. Okay, let's see. So they say a camera person is stationed. Let me go to the next page. Question 7. They say a camera person is stationed at the top of a vertical tower TG, where TG is H. Okay, cool. She films a, oh, my lady, thank you. She films a cat starting at A, where the angle of depression of T after A is theta. Okay, cool. Cool. The camera follows the cat as it walks in the same vertical plane, a distance of x meters horizontally to B, creating the angle beta. Now, 7.1, determine angle B1 in terms of alpha n, in terms of theta and beta. Okay, in terms of theta and beta. Okay, so this is, we're looking for angle B1. Where is it? Yeah, this is angle B1. They say we must determine it in terms of theta and beta. I'm going to show you something. Do you see this dotted line and these lines? As you can see, they are perpendicular. Since this line and this line is perpendicular, this means we can also say as well that this is parallel to this. Now, since this is parallel to this, we can say angle B1, 7.1, where is it? Angle B1 is equal to angle alpha plus angle beta. What's the reason? These are alternate angles. Okay? These are alternate angles. You don't have to give a reason, but because I want you to understand every reason, we will say angle B1 is alpha plus, theta plus beta. Okay? Perfect. Now, let me zoom it here. Now proceeding, we now have, okay, let's see. Proceeding, we now have, let's see, show that x is equal to h sine b over sine into alpha plus beta and then sine beta. Okay, cool. Where is h? Okay, so what we know so far, this is interesting, right? This is very interesting. So what we know, I will say, I want to look at, very interesting, guys, very interesting. Let me just do this. I will say, when I look at triangle, so let me say 7.2, how many marks? It must be some marks, yeah, good. So I will say in triangle BGT, okay, in triangle BG, or GBT, doesn't matter. Okay, BGT, in triangle BGT, okay, I do see that tan angle B1, oh, sorry, not beta, it's P. Tan, is it tan? Should I use tan? Should I use tan? Yeah, let me use tan. Should I? Okay, I'm going to use tan angle B1 equals opposite over this guy, right? So what is this? Opposite over adjacent. So it'll be TB over BG, right? It'll be TB over this guy here, right? So now a question I'm asking myself is this. I do know what angle B1 is. They told me it is alpha plus beta, isn't it? But no, a question I should ask myself is this. What's the use of using, let me see. I said no. Oh man, I'm messing things up. Okay, I'm messing things up. Let me not use tangent. Let me use, which one should I use? I'm going to use TB, because the reason why I'm using TB is this. I have this angle here, so it'll be easier to use angle B2 to find any other thing that I want. So let me say this. Let me say, okay, in that triangle, I'm going to use sine instead of tangent. So I'm going to use sine angle B1, because I see I need to use sine. Angle B1 is equal to what? Opposite over hypotenuse, which is, what is opposite? Opposite is TG. What is hypotenuse? Hypotenuse is TB. So what is TB now? TB is TG over sine angle B1. What is TG? TG is H. TG is H. And then what is B1? Angle B1 they said is theta plus beta. So now I'm okay with that. Okay, now I'm okay with that. Perfect. Now, I already have this side. If I have this side, and now I have this side given here, and a side, an angle opposite to it, angle opposite to it. So I'm gonna say now in triangle, let me say BTA, okay? Let me say in triangle BTA. In triangle BTA, I want you to see this. I have this side here and an angle opposite it. And I also have this side here. But what is this angle opposite it? Is this one here. Do I know what this angle is? Do I? But I can find it, right? So what I know, hold on, I know angle A equals theta. Why? They are alternate angles. Can you see that? They are alternate angles. Okay? Perfect. So now what I can do is this. I can say AB over sine. What is the angle opposite AB? It is angle, let me call it angle BTA for now, okay? Even though I don't have to be saying BTA, I can simply say T because I said in triangle BTA, but it's okay. I will just say BTA. AB over TB. Okay, AB over sine BTA is equal to TB over, where's TB? This is TB. Which angle is opposite TB? It's this angle here. What is this angle? I'm going to call it BAT. Okay, so it's going to be sine angle BAT. Even if you say sine A, it's okay because you said in triangle BTA. Okay, what is AB? AB is X. Sine BTA. Where is BTA? BTA. Here is it. What is it? It's beta. So it's sine beta. Okay? It's sine beta. What is TB? You found TB to be H over sine theta plus beta. And then what is angle BAT? Angle BAT, you found it to be, which is angle A. You found it to be theta. Okay, you found it to be theta. Oh, nice. Now we can say, okay, cross multiplication. This is H sine beta over sine theta plus beta sine theta. Okay, sine theta. Happy? Perfect. Now, proceeding, the question says, determine the distance the cat walked from A to B. If the tower was 20 meters high, let me go to the next page. So 7.3, if X is, determine the value of X. What was X? We said X is H sine beta over sine theta plus beta sine theta. They say the value of H, which is the height of the tower, is 20 meters. So it'll be 20. And then theta is 65 degrees, beta is 37. So beta is 37 degrees. And then this is sine 65 degrees plus 37 degrees, all multiplied by the sine, what? Sine, what is theta? 65 degrees. Then we take our calculator. We see what we get. Let me see what I get quickly. So what I get is, okay, I need to okay. So this is 20 sine 37. Okay, close over sine 65 plus 37 close, sine 65 close. So what is our answer? Our answer is 13.58. Okay, it's meters. It's 13.58 meters. Okay, our answer is 13.58 meters. And this is how you answer your trigonometry. So this is how you are supposed to answer this paper you're holding 2022 November. Okay, this is how you are supposed to answer it. So this is it, guys. I will see you next time, and I hope you ace your exams. So with that being said, it's a wrap, and bye bye.